Right, so in this video I'm going to have a look at the next two questions in the 2016 Maths Higher Level Paper 1. First question here is question 3, and it involves two functions here, 2 over e to the power of x, that's f of x, and e to the power of x minus 1, which is g of x. First part of the question just simply asks us to fill out this table here to 2 decimal places. We've got to work out the y values for each of these x values. That's fairly straightforward. You just stick 0 in here instead of x, 0.5 in here instead of x, 1 in here instead of x, and log 4 in here instead of x. And write down the y values that you get when you do this calculation. Same here with our g of x function. These are the values I got anyway, to 2 decimal places. Now in the next part they ask us just to plot each of those functions or draw each of those functions, which I've done here. Now this I know isn't very accurate, but you get the idea anyway. You plot each of the points. It's a little bit shaky along here, but hopefully you'll be able to do a better job of this than I did. But this will give you a good idea of what the graphs will look like. Now in this part here they ask us to use the graphs to estimate the values of x for which the two functions are equal. F of x is equal to g of x. So it's here anyway, where they intersect is around here, and it looks like it's somewhere around 2, 4, 6, 7, 0.7. I've got a little bit over 0.7 here. I'm going to put down 0.7. I know the actual answer to this is just under 0.7, but my graph isn't too accurate around this area here. So let's say, I mean this is 0.2 here. This is 0.4, this is 0.6, this is 0.8, so it's just a little bit over 0.7 here. So let's just put down f of x here is equal to g of x at x is equal to, let's say, 0.7 here. Okay, but you get the idea of how to do it anyway. You just look at where the two graphs intersect and read off the x value. Now in the next part they actually ask us to do this algebraically. Solve f of x is equal to g of x algebraically. So our you just write down the two functions. Our two functions are 2 over e to the power of x, and we want that to be equal to our g of x, which is e to the power of x minus 1. Okay. Now the best way to solve this initially is, because we have a fraction here, it's usually a good idea to try and get rid of fractions. So let's multiply across by e to the power of x. So if we multiply across by e to the power of x here, we'll get 2. Here we'll get e to the power of x all squared, and here we'll get minus e to the power of x. Okay, let's bring everything over to one side. It looks like some kind of quadratic here, so let's take 0 here, e to the power of x all squared here. This is minus e to the power of x here, and this is minus 2. So a good way of solving these, we got an e to the power of x here and an e to the power of x here. So let's just substitute in a different letter here just to make it easier for us. So let's say we'll call it m. Let's say e to the power of x is equal to m, okay? So we're going to let e to the power of x equal to m. So what we end up with here, we end up with 0 is equal to m squared minus m minus 2. So this will be a little bit easier to do, I think. So okay, so this will give us 0 is equal to, we can solve this, I think, quite easily. We have an m here, we put a 2 in here and a 1 in here. This is a minus, so we want plus times minus. Our largest one here needs to be minus, and this is plus. So that will give us m being equal to 2 or minus 1. So m is equal to 2 or minus 1. Now, we said e to the power of x. Remember, e to the power of x is equal to m. So e to the power of x is equal to 2, or e to the power of x is equal to minus 1. Now, if you look at this one here, e to the power of x, e is just a number. So we're raising this number to the power of some number x here, which we've got to work out. And our answer has to be negative, and that's not going to be possible. you can't raise this positive number e to any power and get a negative solution. So we're going to ignore this one. This one here doesn't work out for us. So e to the power of x here is equal to 2. So let's just work this one out. Well, we can get the log of both sides. So you can get, if you like, I'll do it, let's see, log of e to the power of x is equal to log of 2. So you can see here this is just going to be simply x, and we work out the log of 2 here. The log of 2 is 0.693. So this is our solution here, 0.693. And remember up here when we looked at the graph, because I'm a little bit shaky around here, I got somewhere around just over 0.7. But our actual solution is 0.693, so it's a little bit to the left of this here. Okay, so that's really that one. Let's move on to the next one. This is question 4, and this was proof by induction. It's a proof by induction, and remember we have 3 types to look at. There's divisibility, series, and inequalities. So this is the divisibility one. So let's have a look at proving this. So we got to prove by induction that 8 to the power of n minus 1 is divisible by 7 for all n is an element of n is a natural number. So first thing we're going to do is prove that it is, we're going to show that it is true for n is equal to 1. So when n is equal to 1, is it true? Okay, so let's see, we've got 8 to the power of 1 minus 1. Remember we're looking at natural numbers here, and the first natural number is 1, so we're going to start with 1. That's why we picked 1 here. So 8 to the power of 1 minus 1, that's 8 to the power of 1, which is 8, minus 1, which is 7. 7 is divisible by 7, so this is divisible by 7. So it's true for n is equal to 1. Okay, so the second thing we're going to do now is we're going to assume it's true for some value n is equal to k. So we're going to assume that this is true. So we're going to take, in other words, 8 to the power of k minus 1 is divisible by 7. So this is divisible by 7. We're assuming this is true. So what we want to do then is prove that it is true for n is equal to k plus 1. Prove that it's true for n is equal to k plus n is equal to k plus 1. Given that it is true for n is equal to k. Okay, so what do we actually want to prove then? We want to prove that 8 to the power of k, so we want to prove this. Whoops. We want to prove that 8 to the power of k plus 1 minus 1 is divisible by 7. Okay, so let's do that then. The way we're going to do this is do it by subtraction. We're going to take our 8 to the power of k plus 1 minus 1, subtract our 8 to the power of k minus 1, and see if that's divisible by 7. If it is, then our 8 to the power of k plus 1 minus 1 is divisible by 7. So we're going to take 8 to the power of k plus 1 minus 1. We're going to subtract our 8 to the power of k minus 1. And we're going to see, is that divisible by 7? So let's do that. Well, that's going to give me, let's see, I'm going to break this up into 8 to the power of k times 8 minus 1. Remember, just this is 8 to the power of 1 here if you like. So 8 to the power of k times 8 to the power of 1 is 8 to the power of k plus 1 minus 1. And here we have minus 8 to the power of k, and then minus minus, which is just plus 1. So this will give me 8 times 8 to the power of k. I've just switched these two around. minus 1 plus 1, that'll give me 0, and here I end up with minus 8 to the power of k. Right, next line. I've got an 8 to the power of k here, I've got an 8 to the power of k here, so I'm just going to factorize here. I'm going to take that outside the bracket. So I'm going to take 8 to the power of k here. Here I end up with 8 minus 1, and that will give me 8 to the power of k times 7. So now you can see that 8 to the power of k times 7 is divisible by 7. So that's it. We've proven that when we subtract we do get something that is divisible by 7. So therefore this here is divisible by 7. Therefore 8 to the power of k plus 1 minus 1 is divisible by 7. Okay, so you need to write out then that f to the power of k plus 1 minus 1 minus f to the 8 to the power of k minus 1 is divisible by 7. So I'm kind of running out of room here. You would need to write that out and say, as a result, we conclude that f of k plus 1 is divisible by 7, having assumed that f of k is divisible by 7. So the final line then that you would write is the proposition is true for n is equal to 1. The proposition is true for, I'm just going to run out of room here, for n is equal to 1 if the proposition is true for n is equal to k, then we've just shown it is true for n is equal to k plus 1. Therefore, by induction, it is true for all n is an element of n natural number. Okay, so that's it really. That's our proof by induction. Okay, next one then is part B here. This is a logs question. So we've got to, what are we given here? We're given that the log of 2 to the base a is equal to p and the log of 3 to the base a is equal to q. A is positive. Write each of the following in terms of p and q. So we've got to kind of simplify this here. This is really using your rules or laws of logs here. So I'll just write this down again here. We have the log of 8 over 3 to the base a. So how can we rewrite that? Well, this is a division here. So by one of our laws of logs here, we can write that as the log of 8 to the base a minus the log of 3 to the base a. Now, our log 8 here, we know that log 2 to the base a is p, so we can change this 8 to a 2 to the power of 3 here. So we can say that's log of 2 to the power of 3 to the base a minus log 3. By one of our laws of logs as well, we can take this 3 and bring it down in front of the log here. So we can take that as 3 log 2 to the base a minus log 3. And really that's it now. We know that log 2 to the base a is p. So instead of this part here, we can just write in p. And instead of log 3 here, I should have a base a there as well, by the way. There should be a base a here and a base a here. So instead of that, we can instead of this here, we can just write in q here. So let's just replace those. So we have 3 times p minus q. So we're just asked to write each of the following in terms of p and q, which we have done here. 3p minus q. Okay, next one. So this is something similar again, maybe a little bit longer, but it's the same kind of idea. So let's start. So we have, I'll just write it down, log to the base a, 9a squared over 16. Now remember what we want to do here. We want to end up with log of 2 and log of 3 to the base a. And we see here we've got a 9 and we have a 16. They can be converted to 3's and 2's. So let's just split them up first of all. So we'll take the log of 9a squared first of all to the base a, and it's going to be minus the log of 16 to the base a. Okay, so let's continue on. We can take this, okay, so here we have a 9a squared. Now I could take that 2 and bring it down here, but then I'd be stuck with a 9 and an a here. And the 9 I can convert to a 3, but not the a. So what I might do here is just convert that into log 3a all squared to the base a. There's probably a couple of ways you can approach this, but this is the way I'm going to do it anyway. This here is the log of 16. Now I'm going to change that to 2 to the power of 4. 2 to the power of 4 is just another way of writing 16. So, okay, that's fine. Now I'm going to take this 2 now. I'm going to take the squared now and bring it down here. So that will give me 2 log 3a to the base a minus, and I'll bring this 4 down as well, 4 log 2 to the base a. Okay, so I can take, let's see, what have I got here? I have a log 3 and I have an a here as well. I need to split these up. So I'm going to take this 2 and I'm going to split this up here. So I'm going to take that as log 3 to the base a plus log a to the base a. Because remember these two are multiplied, so I can just add the logs here. And here I've got minus 4 and I've got log 2 to the base a. Now remember, I know that log 2 to the base a is p, so this is going to be, I don't have to do any more with this, it's just going to be 4p here. Underneath here I can just write down 2. Let's see, log 3 to the base a is q, so I can just write that down as q. Log a to the base a is just 1. A to the power of 1 will give me a. And here I end up with minus 4 times log 2 to the base a, and log 2 to the base a is p, so I can just put p in here. Okay, so that's it really. Just to simplify that a bit more, we end up with 2q plus 2 minus 4p. And that's it really, 2q plus 2 minus 4p. Okay, I'll do the next few questions in the next video.